So this is an NEC type of problem. Here it's asking for allowable ampacity. So there's a keyword here. So you already know that you're going to be using one of your table 310 tables, article 310 tables, your ampacity tables. So here we're given that is number 4 AWG, RHW, copper, which is important. So kind of go through your mind and highlight in your mind the keywords. Ambient temperature 50 degrees. So let's go to our table. So here in this table here we have allowable ampacities of conductors up to blah blah blah, not more than 3. So we're given 3 here, so we're good, we're on the right table. So let's look at here, RHW, copper, not aluminum but copper. RHW, size is 4, so here we have 4 and our ampacity is 85 amp. So let's go ahead and write that down, 85 amp. However, this table over here is based on ambient temperature of 30 degrees Celsius. So the question is asking for 50 degrees Celsius. So we know already that we're going to have to do some temperature correction here. So let's go ahead and use our temperature correction table based on 30 degrees Celsius. So this table right here is based on 40 degrees Celsius. That's not applicable for us because we use the table for 30 degrees Celsius. So we're going to come here, table 310, and look at here. So these ambient temperature correction are based on 30 degrees Celsius. So for temperature correction factor, we're going to have to use, we're given 50 degrees, so we are over here, right? Ambient temperature. So the table already is based on 30 degrees. So you look at your whatever the question is asking to correct it to. So we're going to take our ampacity of 85 degrees that's based on 30 degrees and we're going to correct it to a 50 degree Celsius temperature. So here where the confusion is sometimes for students, for PE takers, I guess. So which one of these do you actually use? 60 degrees, 75, or 90? Let's go back to our table, to our 310 B16 table. So when we calculated our 85 over here, this was corresponding to 75 degree insulation, correct? So this is the temperature rating of the conductor. So our RHW conductor is rated at 75 degrees. So we're not using 60, we're not using aluminum or anything like that. We're using copper rated at 75. So when you go to the table, because that's kind of confusing sometimes, when you go to your temperature correction table, you use the 75. Make sure you use the 75, not 60, not anything, but whatever your conductor is rated at, that's what you use. So here we have for our question 50 degrees Celsius, not Fahrenheit but Celsius, rated at 75. So we have here our temperature correction factor is 0.75. So we're gonna multiply 85 times 0.75. all right, so whatever that answer is, I'm going to calculate that. 63.75. amp. So in the exam, I mean, this is fairly straightforward, but in the exam, don't be surprised to see in your multiple choice questions 85 in there, just to kind of trick you into forgetting that you gotta temperature correct, you gotta correct it to the corrected temperature. because that table is based on ambient temperature of 30 degrees Celsius, whereas the question is asking in an ambient temperature of 50 degrees Celsius. So that's how you kind of approach the problem, using two different tables, using your ampacity table and then your temperature correction table. And we're going to practice more problems like this as well.